Welcome to Chapter 3's first lecture for kinematics in two dimensions. Most people are often intimidated when we add a second dimension. But if you have a strong understanding of motion in a first dimension, and you follow the steps for solving these types of problems, it's very easy to view and visualize these types of problems. I hope that you will take your time to focus and follow along with this lecture. When looking at situations that involve motion in two dimensions, we'll need to look at them through a sense of vectors. In this situation here, the first position of the car, or the initial position, is given by r0 from the origin of the xy axis. It has both an x and y component, giving that position. The final position, or final displacement, from the origin is given by r. This also has both an x and y component. In order to find the displacement vector for this little race car that travels around the circle, delta r, all we need to do is through vector subtraction, or you could look at it as vector addition, either way, find that value, find the x and y values for delta r. Once we know the value for delta r, our displacement, we already also know the change in time, from the initial time of t0 to time t. This will give us our change in position, our displacement, over our change in time, which will give us our velocity. The big thing here is looking at it through a vector standpoint. As long as you can do the vector analysis for a simple problem like this, then you'll have no problem for anything in this section. As already mentioned, when analyzing situations in two dimensions, we really only need to look at the vector components, the x and y part. Here, we have a car with velocity v, of which there is a x component to the velocity and a y component to the velocity. By knowing the magnitude of v and the angle that it's at, we can solve for the x and y components. Within any initial velocity, there is both an initial x velocity and initial y velocity. This would be v0 x and v0 y. The same goes for a final velocity. There is still a v final x and v final y. Keep in mind that when asked to solve for the velocity of something in two dimensions, it is not merely asking you to solve for the velocity in the x direction or the velocity in the y directions. Those are just components for the resultant of that total velocity. So you need to use both of those values and the Pythagorean theorem, or if you know the angle, you can use some trig to figure it out too, to solve for either the initial velocity or the final velocity, depending on what the question is asking. Similarly, any acceleration given as a vector A has both an x and y component and can be broken into those. We will not worry about any change in acceleration, as we will just be dealing mainly with a constant acceleration throughout this course. We can now take our three main equations that we dealt with in just one dimension and split them up so that they are each represented for both dimensions in the x and y direction. Here we have the same set of equations, just with different subscripts for each direction. Please make sure to copy these down in your notebook, bold them, star them, outline them, whatever it is necessary to make sure that you fully remember how to split this up. As we get further and further ahead, it's going to be more and more important for you to follow along with these and be able to know them kind of by heart. Let's take a look at a sample problem. Here we will look at a spacecraft as it accelerates into a two-dimensional space. It has an initial velocity that has both an x and y component, and it also has an acceleration that both has an x and y component. We will consider it to have a constant acceleration and throughout its flight. Things that we will be looking for are its change in position, so it's change in x and change in y, and the change in the final velocity, both in the x and y components. Here are the initial conditions. To make this problem a little bit easier, we can assume that the spacecraft started at the origin, so that way its initial x and initial y position can be 0. Make sure to take these values down in your notes and follow along with the kinematics equations that you've already recorded there. Let's start by dealing with the components in the horizontal direction. One of the nice things about problems in 2 dimensions is that you can split each part into its own components, x and y, and look at them separately. You don't have to worry about each part at the same time. You can look at them individually. Here we have our spaceship with an initial velocity of 300 meters per second and having an acceleration in the x direction of 200 meters per second squared. Now this accelerates for 3 seconds. Using your equations for the x direction and what we know, solve for the final velocity in the x direction and the final position in the x direction. Keep in mind that we are going to set this initial position to be 0. That's x naught. So take a moment and do your work in your notebook right now. Now that you've solved for all the necessary information in the horizontal direction, the x direction, we can now concern ourselves with the vertical components. In the vertical direction, we have an initial velocity of 100 meters per second and a constant acceleration of 50 meters per second squared. Keep in mind that once again, we're going to say that the initial position in the vertical direction is 0. And this is accelerating, the spaceship is accelerating for a total of 3 seconds. Use this information and your kinematics equations for the y direction to solve for the final velocity in the y direction and the final position in the y direction, the y direction. Now that you have both your final velocity in the x and y direction and the total displacement in the x and y direction, we can now use trigonometry and the Pythagorean theorem to solve for displacement, the vector r, and our velocity vector. Please make sure to include the angle with each one of these final measurements. Make sure to show your work and put a box around your answer in your notebook. To infinity and beyond.